The Sky This Month with your host, Dave McDonald.
Welcome to The Sky This Month. I'm your host, Dave McDonald, and it's October 2022, and again, a great show in store for you. In a moment, I'm going to be introducing to you Todd Barber, who is the Chief Propulsion Engineer for NASA and JPL, and one of a few people that control the Voyager spacecraft. We're going to talk all about that. How would you like to see Halley's Comet? This month, you get to see Halley's Comet. I'm going to explain about how and when you can do that towards the end of the show when we have our Star Talk. And I want to bring up to you the Superstellar Friday at the McAuliffe Shepard Discovery Center. That is going to be November 4th, Friday night. Exoplanets, they're out of this world. Dr. Andrew Jordan, the UNH research scientist, will be there. Yours truly will be there. And the Belmont High School Astronomy Club is entered into a naming contest for stars and exoplanets, sponsored by the International Astronomical Union and NASA, and they're going to give their presentations about that. So it's going to be a great evening, Friday night, November 4th, at the McAuliffe Shepard Discovery Center in Concord. Don't miss it. Well, right now it gives me great pleasure to introduce to you Todd Barber, who is, as I said, the Chief Propulsion Engineer for NASA and JPL. He's responsible for getting Curiosity and Perseverance to Mars safely, and now he's one of a few people who are involved in keeping the Voyagers happy and healthy. So he's going to share a great update on the Voyager spacecraft. So from Pasadena, California, welcome, Todd.
Thanks, Dave. Delighted to be back and to talk about my first planetary science love with the Voyager mission.
That's
and
awesome.
I take some questions today, but I also have a little slideshow just kind of where the mission's at today.
So Todd, tell us about the Voyager missions that are now in their 45th year.
We are in the year 2022, and if you do the math with a 1977 launch, that means we are 45 years and counting this month and last month from the launch of these two beautiful spacecraft. And they're still going. So they are the longest lived NASA explorers, and they are also the most distant NASA explorers. As you might imagine, if something launched 45 years ago, the technology is more than 45 years old. It's really mid-70s technology. And just to put a couple things in context, Voyager 1 and 2 do have computers on board, but the memory is about 69 kilobytes. Move over, we're rapidly approaching the iPhone 5 level, but at least we're only 250,000 times less memories than an iPhone 5. And I still am rocking the flip phone, so I think iPhone 5 is not exactly state of the art either. But compared to Voyager, it's vastly superior. Now, this was a stretch goal for NASA at the time we launched, because nothing had lived more than about a year in space, because that's about what you needed to get to Mars and do a mission. So it was already a stretch goal to get to Jupiter and Saturn and play back the data. That was a 5-year kind of time frame. So when people could use the slightly better part or do a little better radiation shielding, make the spacecraft built for longevity, they did so. And that allowed us then to complete the Jupiter and Saturn portion of the mission. In fact, if we were really lucky, then maybe we could go on and complete this grand tour, which I'll talk about in the next slide, going also to Uranus and Neptune with Voyager 2. But that would require something living a dozen years after launch, which was absolutely unprecedented at the time as far as NASA missions go. But I don't think anyone could have dreamt, even after the success with the planetary missions, that we'd be here in 2022 talking to two 45-year-old spacecraft, and they're still getting the job done.
Nice.
So the beauty of Voyager, and some genius graduate student, UCLA, Caltech, recognized this in the 1960s and came to JPL and said, the planets are aligning. It sounds like the sky is falling, but this was actually true. JPL dismissed this graduate student, said, this is mathematical hocus pocus. It looks good on paper, but it's not practical. It doesn't work. Of course, JPL was wrong there, and this graduate student was right. And as it turns out, the 4 gas giant outer planets, Jupiter, Saturn, Uranus, and Neptune, were all lining up on the same side of the sun. And this only happens every 176 years. So once they realized this, they went to Nixon's office in the early 70s and said, now look, Mr. Nixon, the planets are aligning. 1977, you can get all 4 gas giants with one planet, with one spacecraft. And it only happens every 176 years. So the last time this worked was 1801, and Jefferson blew it. Don't make the same mistake. You have to give it up for Richard Nixon there for having the foresight. Now, a Hohmann transfer orbit is a minimum energy trip to Neptune. That takes 30 years. We shaved 18 years off that flight time. We could get to Neptune in 12 years. So all 4 gas giants, Jupiter, Saturn, Uranus, Neptune, within a dozen years. So that was the appeal of the Grand Tour. Now, drove the press crazy because, as you see on our chart here, in blue is Voyager 1, red is Voyager 2. And Voyager 2 launched first. And the press could never grasp this concept, even though, we thought it'd be better to confuse them at launch than for the rest of the mission. Because Voyager 1 was faster, overtook Voyager 2, and got to Jupiter first. But those are the dates there. August 20th, 1977 for Voyager 2 launch, September 5th, 1977 for Voyager 1 launch. It was just on a different trajectory. So we just, because of the launch period, that put it on a faster trip. And we knew to get it to Saturn and to target Titan, which I'll talk about in a second. But basically, we can control that a little bit with the Titan Centaur and then this upper solid rocket stage that put the Voyagers on the path to Jupiter. They flew by Jupiter using this technique of gravity assist, bent the path, and then that put us out to Saturn. And Saturn's large moon Titan, second biggest moon in the solar system, was such an interesting target that Voyager 1 was targeted to fly by that, sacrificing Uranus and Neptune. And the idea was you get your Titan data, and if and only if that worked, you redirect Voyager 2 to fly in the Saturn system at a point that would take you on to Uranus and Neptune. But if we'd have failed with the Titan encounter with Voyager 1, we actually would still not have had a mission to Uranus or Neptune. So thankfully that worked. Now, as it turns out, Titan was a bland orange cue ball, and we couldn't see the surface, so we had to wait for the Cassini mission to take radar and the Huygens probe to actually tease out the secrets of Titan's surface. But we knew we wouldn't learn much more from Voyager 2 that Voyager 1 didn't already tell us. So we were able to preserve the rest of the Grand Tour, heading out to Uranus in 1986 and Neptune in 1989. The Voyager 1 flyby of Titan flung us out of the plane of the planets to the north, as you can see in your diagram there. And Voyager 2, we dove over the north pole of Neptune to snag Neptune's interesting moon Triton, which orbits Neptune backwards, a captured object for sure. And that put us south of the ecliptic plane, way low. So in fact, today, the only antenna that can hear from Voyager 2 and talk to it are in the southern hemisphere. So at least they don't compete for our love. They're on opposite solar latitudes, interplanetary latitudes, if you will. So that's the good news. Here's the scale of the planets, just to remind everyone. Everything we do in our biz, the planetary world, we define a new unit called the AU, astronomical unit, 93 million miles, 150 million kilometers, average distance of the Earth to the sun. So Jupiter's at 5 AU, Saturn's at 10 AU, Uranus is at 19, Neptune's all the way out at 30 AU. And the size of the planets are to scale in this diagram, not the distance between them, but compared to the wee Earth at the bottom center.
Todd, what are some of the neat things that the Voyagers have discovered on their grand tour from Jupiter to Neptune and their moons? What are some of the great discoveries?
So along the way, of course, we discovered incredible things. We didn't discover the Great Red Spot. All telescopic observers know that as soon as we had telescopes good enough to see the red spot, it's there, although it's been kind of fading and disappearing a little bit in the last few decades. But it's a hurricane 2 or 3 times the size of the Earth. And of course, we had a front row seat with Voyager checking that out. We also made probably the biggest discovery of the whole planetary portion of the mission were the Io volcanoes. Turns out Io is a moon of Jupiter that is squeezed and flexed by Jupiter's tidal force, along with the moons Europa and Ganymede. And what this does is it melts the Io interior, 3,000-degree lavas, 10 to 100 times more volcanically active than the Earth. A huge surprise. These were not going to be boring, dead, geologically dead, icy moons in the outer solar system. Nature always was better than our imaginations could be. On to Saturn, the gem discovered many new moons, spokes in the rings, shepherding moons, keeping the ring particles in place. Beautifully successful part of the mission in the early 1980s. On to Uranus. Uranus, we called kind of the plain Jane of the solar system. We had to stretch the contrast to get any color at all within the cloud decks. Both Uranus and Neptune have methane in their atmospheres, which absorbs red light, which gives it a bluish color. It's not due to water, it's the methane that's there. So Uranus is tipped on its side, and we came in northern summer. As you can see, we've stretched the contrast to show the Uranian North Pole. Now, because the planets all orbit Uranus near the equatorial plane, we had to pick and choose. It's kind of like a bullseye target. We couldn't fly by all the moons as we could at the other gas giant outer planets. So we picked a moon called Miranda to fly by closely, and that turned out to be a really good choice, as you'll see in one of the images coming up. By the way, all the moons of Uranus are named after characters in Shakespeare, which is definitely a weak area for me academically. So I've learned more about my Shakespearean names from Uranian satellites than from studying Shakespeare. And there is Miranda on the left, Titania on the right, but Miranda kind of stole the show. This was a really strange moon. It looks like a bunch of parts were squeezed and put together. And that's exactly what we think happened. A moon probably got pummeled by comet or asteroid, broke apart. The pieces self-assembled in this kind of hodgepodge of different terrains and jagged cliffs and things like that. So Miranda is definitely a bizarre place in the outer solar system. Another bizarre thing from Uranus was the magnetic field. It was tilted drastically versus the rotational axis. In fact, something like 59 degrees. So your compasses on Uranus would point more towards the equators than the poles. And even stranger, it doesn't go through the center of Uranus. So they're still trying to understand that. Maybe it was something wrong with the instruments. Turns out we went by Neptune and saw the same thing. So it is something weird in those outer planet atmospheres, deep interiors. And Neptune, we flew August of '89 with Voyager 2, found a great dark spot. We need some artists on this mission. It's like cave people name these, great red spot, great dark spot. Not very poetic, but that's a hurricane the size of Earth. I believe just today I saw James Webb Space Telescope took a picture of Uranus and its rings. So it's exciting to see there's still cloud features in the Neptune atmosphere. And then the fastest winds in the solar system are here as well, 1,400 miles an hour, which was a real surprise. But then we realized when it gets super cold, the friction gets very low, and then things can just accelerate to very high speeds. And as with Uranus, the moons are named after Shakespeare characters. For Neptune, they're named after gods and goddesses of the sea. So lots of maritime kind of connections there. Collection of moons on the left. On the right side, this was a surprise. Neptune had clumpy rings. Rings should be uniform around the circumference because any particles should spread out. So the fact that there were thicker ring materials at certain angles made no sense. So we're still trying to understand that. It might be some shepherding moons herding particles into little groups, but a big surprise then for the last part of the planetary mission. But again, Triton stole the show. We purposely flew by this moon, not knowing anything about it. And this is what popped us out of the plane of the solar system. But look at that bizarre terrain, huge lack of impact craters, the strange cantaloupe terrain. But the biggest surprise of all, a few tens of degrees above absolute zero, and yet active nitrogen geysers that were spewing black smokers, clouds up into the very thin Triton atmosphere, and then depositing those black materials downstream. But no one would have ever guessed that this close to absolute zero, we'd have a geologically active body. So a nice end to the planetary portion of the mission.
I understand Carl Sagan had a special request after Voyager passed Neptune to turn around with its camera and point it back towards Earth and take a shot. And I understand that NASA turned him down, JPL turned him down, and he went to Congress to get approval for that now historic, iconic shot, the pale blue dot.
Eventually, Carl gets what he wants, and of course, as he pointed out, there's no science in these, but never question the great Carl Sagan, because this ended up being, they say, the picture that launched 1,000 environmentalists, because we see Neptune, Uranus, Saturn. Now, Mars and Mercury are too close to the sun, but most fortuitously, in a sunbeam, caused by dust within the camera, there is one tiny blue pixel, and that is Earth. And from that image, the term pale blue dot was born. And Carl wrote a book with that title. So a last picture show for Voyager, and what a way to go out.
So now we're beyond the planets and the moons. We're in interstellar space. No more pretty pictures. What are the instruments now telling us?
We turn the cameras off, but that leaves 5 field and particles instruments on the spacecraft: magnetometer, plasma wave antennas, low energy charged particle detectors, cosmic ray detectors, and a plasma subsystem. Okay, the sun puts out a solar wind, as we see here, but the sun moves around the center of the Milky Way every 225 million years from right to left here. So the interstellar flow bends this heliosphere, back into like a comet tail, and then the heliopause is the moment where the solar wind goes from supersonic to subsonic. Now, as it turns out, Voyager 1 and Voyager 2 in this diagram are heading to the left. If they were heading to the right, they'd be buried in the red region and never would leave the heliopause. So we got very lucky that the direction happened to be to the left here. And so we've actually crossed the heliopause for Voyager 1 in 2012, Voyager 2 in 2018. And we didn't know where the heliopause was. We never thought the spacecraft would last long enough to get there. And the more we waited, it's further out than we thought. But we're actually in interstellar space right now in that light blue region before the bow shock. So we are looking to measure the magnetic field of interstellar space. And what we found, I've got other slides that'll show this, but it's very lucky we're the first spacecraft out there, and we're doing in situ measurements to help our modelers figure out what the space between the stars is truly like. And one thing we found is we owe our heliosphere a debt of gratitude, because, and this is Voyager 1 data, after 2012, the cosmic ray flux has been constant, but notice it's about 5 times higher in interstellar space than it is back around launch. So what that tells us is about 80% of the cosmic rays that are heading to the Earth to scramble our DNA, 80% are filtered out by being deflected by the heliosphere. So thank your heliosphere today for taking 80% of the cosmic rays away from planet Earth.
So thank you, heliosphere, for keeping us safe. Well, Todd, where are the Voyagers now? And we're recording this on September 21st, 2022. Where are the Voyagers now?
I pulled the data from today for each spacecraft, and this is available, by the way, on voyager.jpl.nasa.gov all the time, and it's updated every second. So it has our launch date, what the mission elapsed time is since launch. So notice we've crossed the 45-year threshold. We are 16.7 billion miles from Earth for Voyager 1, or 158 AU, astronomical units. Remember, Neptune was a mere 30 away. When will we be one light day away from Earth on Voyager 1? That should be celebrated. It's a big milestone. The answer is November of 2026, so it's not so far away. And conveniently, that's only about 8 months before our golden anniversary, if we make it that far, to 50 years. So I think we should celebrate, but maybe not too much, because remember, that's one light day away from Earth after 50 years of travel, whereas the nearest star is 4 light years away from Earth. So after 50 years, we're 1/1500th of the way to the nearest star. Kind of depressing to realize the scale of interstellar space. So even though we've escaped the sun, we've got a long way to go till we get to the nearest star. So if those stars have planets and intelligent life, maybe they'll find the Voyagers and check out what we sent them.
One of the most famous aspects of the Voyager missions are the golden records that they carry. Each one carries one golden record. What's the significance of the golden record? How does it work? And why did we do this golden record project?
It looks rather cryptic, but our contention is if an alien species is smart enough to find a cold hunk of dead metal floating, within some light years of their own star, they'll be smart enough to decode the gold record. But we wanted to help them as much as possible, and there's a roadmap for decoding it on the cover of the record itself, and that's what you see on your screen. So first off, we did not send speakers or a stereo. They got to build that themselves, but we sent the record and a stylus, and the upper left shows them how to play the record, the view from above. And then right below that's a side view. Now, of course, they don't know how fast to play the record, and they don't know what a meter is or an inch or a foot or a year or a second. So we need to define time and length scales that aliens would understand. And so we picked things that never change across the universe, billions of years or hundreds of thousands of light years. And that's the size of a hydrogen atom and the transition time of an electron in the hydrogen atom. So that's kind of shown at the lower right. So if certainly they've seen hydrogen and know these two constants, from that we can define all our length and time and speed scales that an alien would understand. We also have pictures on this record. You can send the signal into a digital analyzer, the product of two prime numbers. The instructions for doing that are in the upper right. And if they've done it right, then they get a calibration circle, which is center right. That shows them that they've got the first image correct. And because a circle is a circle across the universe, they'll know they've done it correctly. For the pictures, they said, do we show war, disease, famine, the real side of humanity? It's kind of like a first date with the universe. Let's just show them the good stuff first, and then we'll show the ugly side, second, third date. So it's a little bit whitewash, if you will. The music is interesting. There's all kinds of interesting selections on there. The Beatles were offered the chance to be on the record. They said yes, but the production manager said no. So I like to think we keep the Beatles for ourselves on planet Earth. Most represented composer is Beethoven, and personally, I love that. I'm a pianist, and my piano teacher's teacher was Beethoven. So she had a genealogical chart made up of our pedagogical piano line. So we played a lot of Beethoven. It's kind of fun to think we've shared him with the universe now. It's a little scary to think, though, if we don't learn to take care of ourselves and our home planet, one day the sun will blow it up to a red giant. And if we've not become a multi-solar system, interstellar species, this could end up being the only proof humanity ever existed, because it will forever encircle the center of the Milky Way every 225 million years, just like the sun, even though it'll never see the sun again. So we took it seriously that this represents the best of humanity and will outlive us all.
It's really amazing to think about that those golden records may eventually be the only evidence that us humans existed in the universe, because they're going to be traveling on for billions of years. Well, speaking of years, we just passed the 45-year mark. Did you guys have any celebrations?
So we did have a big celebration at JPL. We brought in 4 of the prior JPL lab directors, and the current project manager spoke. The project scientist, Ed Stone, was there, and we talked about the mission, screened a new documentary about Voyager that has been released on the JPL website called The Footsteps of Voyager. And we also, of course, had some cake. But it was a really great celebration of 45 years and counting.
Well, 45 years down, how many years left to go? And what might be the cause or the causes of the demise of the Voyagers? So,
with two 45-year-old spacecraft, geriatric spacecraft, every day is a gift, and something could kill us tomorrow. But if we're super lucky, maybe we'd get as far as the early 2030s. Definitely don't hold me to that, but that would take us through this 50th anniversary. And the problem now is everything's cold and we're running out of power. So we've already turned off most of the science instrument survival heaters. That was expected to kill those instruments, because their instruments are 100 degrees Fahrenheit colder than anything they've seen on the ground or in space, and yet they're all still working. So that's incredible. But eventually we run out of those tricks to play. So we'll have to start turning off science instruments one by one, real Sophie's choice. We'll do that at the last possible minute, and then different instruments on different spacecraft, so we can keep one of each type running, in interstellar space. But at some point, though, a propellant line will freeze, or we'll run out of propellant, or we'll run out of power, or the telecommunication signal will be too far away from Earth to talk to it, or we might run out of funding. That's always a possibility, because we get funded year to year.
Well, Todd, these spacecraft have been traveling for 45 years, unprecedented in any spacecraft history. Have you run into any issues or any problems with one or both of the spacecraft?
Back in March or April, we suddenly had just garbage telemetry from our entire attitude control system. It was basically just either all ones or all zeros. And so we had no information on thruster health, star tracker, sun sensor. Now, we knew the spacecraft was probably fine because we were still getting science data back 100%, and it was still clearly pointing at the Earth, or we wouldn't have a signal at all. But it was very frustrating to have no data on the health and safety of the attitude control system. Well, it turns out we caucused and got retired engineers together, and we figured that problem out, solved it, actually sent a command that has restored our telemetry on Voyager 1. So that's the good news. The bad news is that whatever the root cause of that was, we're still not quite sure, and it still could be lurking out there. So we got to try to get a handle of that on Voyager 1 and then see if it could possibly affect Voyager 2 as well. So cautiously optimistic, but certainly a great day of celebration when we fix that very tough, thorny problem.
So Todd, thank you so much for being with us on the show and helping us celebrate the 45th anniversary of the Voyagers. And I appreciate the time you spent with us for this Voyager update.
My pleasure, Dave. And I guess everyone mark your calendars for August and September of 2027. We're going to try to throw a heck of a party if we're still alive and kicking with Voyager 1 and or Voyager 2. Thank you very much, and clear skies to you.
Well, thanks, Todd, and right back at you. Now let's take a look at the night sky, the planets, constellations, and when and how you can see Halley's Comet. Hope you enjoyed that interview with Todd. Fascinating stuff about the Voyagers. Well, I'm sure everybody's wondering, when and where can I see Halley's Comet? Well, this is the answer. October 21st, your best chances are after midnight, is the Orionid meteor shower. And you can see Orion, the constellation of Orion is the famous Orion's belt. So this is after midnight on the early morning of the 21st. And the radiant, what we call the radiant, where all the meteors will appear to be coming from, is just above Betelgeuse. So when you're looking up in the sky and you see a meteor flash, trace it backwards, and if it ends up around that spot above Betelgeuse, then you know it's a genuine Orionid. And what does that have to do with Halley's Comet? Well, meteor showers are dust trails that are left over from comets that pass by. So when you look at an Orionid meteor, you're looking at actual dust particle interactions with the Earth's atmosphere that are from Halley's Comet. So you're not looking at the nucleus of the comet itself, but you're looking at the debris burning up in Earth's atmosphere from Halley's Comet. Kind of cool. And one of the neat bonuses that we have is we have a red triangle. I call it the red triangle. Aldebaran is actually kind of orangish, but again, after the 21st, you have Aldebaran, the eye of the bull. You have the planet Mars, the red planet Mars, and you have the red star, Betelgeuse. And that is just a great photographic opportunity. And if you leave your lens open, your shutter open, you may catch some meteors going through there as well. The red triangle, Aldebaran, Mars, and Betelgeuse. Next, I want to show you the lay of the land with the planets all together. And so we're looking southeast. Southeast, we have the planet Saturn, which is the brightest object in that area of the sky. Kind of looks a little yellowish. You can't miss blazing Jupiter. It's the brightest object in the night sky during this time, unless the moon's in the area, which it's not on this night. This is still the 21st. And then we have Mars, that I already talked about, but it's kind of neat. On this, around 10 o'clock at night, you can see Mars and Jupiter and Saturn. So what constellations are they in? Well, if you look at the constellation pictures, the images that are coming up, you see that Saturn is in Capricorn, which is just off of your screen. Then we have Aquarius, and Jupiter is kind of in the borderline between Pisces and Cetus, the sea monster, but it's technically in Pisces, is where Jupiter is located. And then Mars is at the horns of the bull, Taurus. So kind of neat things to see, some constellations and the planets that are in those constellations. Then just a reminder for as we conclude the show is don't forget Superstellar Friday, November 4th. Friday night, we're going to be talking about exoplanets with Dr. Jordan, myself, the Belmont High School Astronomy Club will be there, and that's at the McAuliffe Shepherd Discovery Center in Concord, New Hampshire. So I'm Dave McDonald for The Sky This Month. Hope that you enjoyed the show.